Hey everybody, welcome to a video on solving systems of equations by substitution. We're going to have three variables. None of them are solved, meaning none of them have like x equals whatever, y equals whatever, z equals whatever. I did make it a little bit easier by making this top equation only have two variables. That's going to help this problem go a little bit faster, but it will still take kind of a long time. So with with substitution, when you're solving these by hand, you really just need to be patient. So the first thing you need to do is solve one of the equations for a variable. And the easiest variable to solve for is x in that first equation. All I have to do is add 3y to the other side, and I'm going to get x equals 3y minus 5. You could say negative 5 plus 3y, but 3y minus 5 is technically the correct way. You always put the letter terms before the constant terms. Constant terms don't have any letters with them. But once you have an x equals equation, or an equation solved for a variable, doesn't have to be x, but in this case, it's the easiest thing to do. You plug it into one of the other two equations, so it doesn't really matter which one you plug it into, so I'm just going to move it down to the middle equation, and I'll sub it in right there. Okay, so you can see that instead of writing negative 2x, I put negative 2 parentheses 3y minus 5. I subbed out the x because this problem's equal to x, this equation I should say. So 3y minus 5 can go in place of any x we have. And so you just copy the rest of the equation down. The only thing we've done is sub out the x and sub in the 3y minus 5. And now we need to distribute. So I'm going to multiply just the insides of the parenthesis by negative 2. So I'll have, what was that, negative 6y plus 10, and then everything else comes down, plus 4y plus 5z equals 21. Okay, so now we can add like terms. So I need to combine my y terms, and that's going to give me what? Negative 2y. And so we have negative 2y plus 10 plus 5z equals 21. And that 10's a constant term. I can pretty much get rid of that 10 by minusing it over to the other side. And so I have, what is that, negative 2y plus 5z, and that's going to equal 11 because negative 21 minus 10 is positive 11. And so at this point, you can decide, do I need to solve this for y or should I solve this for z? And really, there's no wrong answer, but see how the first equation we solved, when we solved it for x, it said 3y minus 5. I'm going to solve this for z, so that way it has the y term on the other side, just like the first equation we solved did. So I'm going to add 2y over, and that's going to give me 5z equals 2y plus 11. At this point, we need to divide everything by 5. You can convert these to decimals if you want. My advice is if that decimal is continuous, like it's like 0.3, 0.6, whatever, keep it as a fraction. And if it ends in like 0.5, 0.25, something like that, where it stops, then you could write the decimal if you wanted. But for me, I'm going to keep it as a fraction. So I have z equals 2y over 5 plus 11 over 5. And so you see the x equals equation and the z equals equation both have something in common. They both equal something with the y in it. So that's important because when you take this and you plug it into the third equation now we go all the way back up to this third equation, we're going to plug in the 3y minus 5 for x, and then we're going to plug in the 2 over 5y plus 11 over 5 in for z right there. And so we'll only have the letter y now. So let me write it all down. Okay, so I went ahead and I just copied down the third equation as it was given originally, And so I subbed out that x as I mentioned. So I have 3y minus 5, and then I subbed out the z with that 2 over 5y plus 11 over 5. So you see here we only have the letter y now, which means after I distribute combined like terms, I can solve this equation for y, and then I can go back and I'll plug it in and I'll figure out x and z. So right now I'm going to distribute the 10 to the inside of the parentheses, and so that's going to give me 30y minus, what's that, 50, and then bring down the minus 3y, and then we're going to do negative 7 times 2 over 5y. So that's going to be negative 14 over 5y. And then we're going to do negative 7 times 11 over 5. So it's going to give me negative 77 over 5. And then it's just going to equal negative 17. So yeah, we got some fractions here. That's pretty normal when you're doing these substitution problems. You get a lot of fractions or decimals. But yeah, so we're going to combine our 3y terms. And so we have 30y minus 3y minus 14 over 5y. You can go ahead and like type that into like a scientific calculator. Um, It'll give you the fraction form. So it's going to be 121 over 5y. And then we have next to it, we have minus 50 minus 77 over 5. So negative 50 minus 77 over 5 is going to equal negative 327 over 5. And that's going to equal negative 17. And so now we just have like a two-step equation, right? We got to get this 327 over 5 to the other side and then get rid of that 121 over 5. So I can simply get rid of the 327 over 5 by adding it to both sides, right? So negative 7 plus 327 over 5, and that's going to equal, what's that equal? 242 over 5. Okay, so when I added negative 17 plus 327 over 5, it got me 242 over 5. I bring down the 121 over 5y. And so you can kind of tell that the denominators are the same. So you can kind of ignore the denominators. If I have 121y equals 242, 121 times 2 is 242. So you might see that in your head. If not, we're going to clear out this fraction by flipping and multiplying it to both sides. It's called multiply by the reciprocal. And so what that does is it cancels out any fraction you have. If I multiply this by 5 over 121, you see it's going to be dividing 121 over 121, which would cancel, and 5 over 5 cancels. So whenever, anything divided by itself is 1. So we're left with 1y when we do that. And then what we do to one side, we have to do to the other. So multiplying this by 5 over 121, again, these 5s are basically going to cancel, and 242 divided by 121 is just 2. Okay? So yes, all that work with the fractions just to get a normal number like 2. But now that we know y equals 2, we can go back and we can figure out x, because x equals 3y minus 5. So we just say x equals 3 times 2 minus 5. And so 3 times 2 is 6. 6 minus 5 is 1. So we have x equals 1. Okay, so that was quick. Usually it's you do a lot of work to find one of the answers and then not a whole lot of work to find the other two. Because we have another equation that says z equals 2 over 5y. So we're going to go 2 over 5, and y was 2, and plus 11 over 5, right? Okay, so 2 over 5 times 2 is going to equal 4 over 5. And so we have 4 over 5 plus 11 over 5. And 4 over 5 plus 11 over 5 is 15 over 5. And 15 over 5 is 3. So really all we can write is, or what I need to write now is z equals 3. And so once you get all three variables, you're done. So I got z equals 3. It's all kind of messed up. Z equals 3, y equals 2, x equals 1. So you always want to write your answer as an ordered triple. So you're going to say 1, comma 2, comma 3, x, comma y, comma z, alphabetical order. And so, yeah, that's the answer. That's the video. Thank you for watching, and goodbye.